Our first word problem for piecewise functions involves an amusement park. So children 5 and under get in free. Children over 5 and up to 12 have to pay $5 to get in. 12 up to 18 is $12 and adults are $18. So this is definitely a step function. You would start this by writing f of x equals in the middle and then a big bracket that will contain all of the sub-functions of this piecewise function. Our first little sub-function is when x is going to be the age of the person, when x is 5 and under. What numerical value would you give to the word free? How much would you pay to get in? 0. So we pay 0 when x, our age, is under 5. Now it says 5 and under, so are we including 5 years old in that one? So we put an equal sign. Now technically, can x be negative in this example? Can we have a kid that's negative 2 years old? No. So we really should do 0 is less than or equal to x is less than or equal to 5. If you were writing this and you happened to forget that portion, I wouldn't necessarily count it wrong, but it is good to include it. Okay, the next one is $5. So this function is going to equal $5. We're going to pay $5 when children are over 5 and up to 12. So here's what I'm going to do. I'm going to write 5 space x space 12. So this is ages 5 to 12, and we just have to figure out what symbols to put in here. Okay? I'm going to start with the 12. It says up to and including 12 years. So the age can be smaller than 12 or equal to 12. X also needs to be bigger than 5. But think about the previous line. In the previous line, x could equal 5. In a piecewise function, you can't reuse an x value. So if 5 is used in that first subfunction, you can't use 5 in the second one. So this one needs to be just plain less than. If a kid is exactly 5 years old, they pay 0. If they're more than 5 years old, then they pay $5. So that second subfunction can't include 5. Okay, what's the next value? $12. And this is for 12 years up to and including 18 years. And you might start to see a pattern. Because on the green line we included 12, can we include 12 on the purple line? No, so this needs to be plain less than. So x can be bigger than 12, and x can be smaller than or equal to 18. And our last value is $18. We pay $18 if we are an adult, which based on the previous information, that would be over 18. Can we include 18 on the gray line? No, so x needs to be bigger than 18, not including 18. Now that we have done that type of step piecewise function together, if I gave you a problem like that in an assignment or on a quiz or on a test, do you feel like you could make it work? Yes? No? Maybe so? Name? A gift shop sells pewter mugs for $35. They are currently running an engraving promotion. The first 6 letters are engraved free. Each additional letter costs 20 cents. Write a piecewise model that gives the price of each, the price of the much, the The price of the mug, that should say mug, not much. You know, mug, much, it's the same thing, right? With X engraved letters. The first part of this piecewise function is going to be super simple. How much does the mug cost? $35. When X, our number of engraved letters, is between 0 and 6 letters. So whether you get 0 letters engraved or 6 letters engraved, you're going to spend $35 on this mug. The next function is a little bit more complicated, and I don't expect any of you to be able to just, bam, write it down first time without trying something out. So over here, I'm going to write down that if we have 6 letters engraved, we spend $35. If we engrave 7 letters, how much is that going to cost us? $35.20. We've added 20 cents once. If we get 8 letters engraved, it's going to cost us $35.40. Notice we've added 20 cents twice. So what we're doing is $35 plus 20 cents. And then right here in these parentheses, we need to figure out how to indicate how many times we need to add 20 cents. So when there were 7 letters, we added 20 cents once. When there were 8 letters, we added 20 cents twice. How could we maybe get those numbers using 7 and 8? How can you get 1 using the number 7? 7 minus how many? How many letters are free? If we do 7 minus 6, would we get 1? If we did 8 minus 6, would we get 2? So the number of letters minus 6 would give us the number of times we have to add 20 cents. And you could check this. 7 minus 6 is 1. 35 plus 20 cents is 35.20. Plug in 8. 8 minus 6 is 2, so we'd be adding 40 cents, $35.40. So our second function is 35 plus 0.2 times x minus 6. In a perfect world, I would say multiply that out, simplify it, make it look super pretty, but it doesn't really matter. And this is for any number of letters larger than 6. This problem is actually a really classic use of piecewise functions, because if you tried to use 4 letters, if you tried to use this second function with 4 letters, you'd end up decreasing the cost of the mug. But because of these conditions, it's saying if you're only using 4 letters, you have to use that first function, not the second function. So the piecewise function, because of these conditions, tells you specifically which price, which function to use based on your x value. So on your own, what is the price of a mug with the name Mary Ellen Gilmore engraved on it? It's a great name, isn't it? It's a really great name right there. Okay. On the next page, there's another word problem. It's a lot more complex. And I'll be honest, I'm not going to give you a problem like that on your assignment or on a test or a quiz. So, do we need to do it? If you would like to do number 3 and check it with me, I would gladly look over it with you, but we don't need to do that.